Hello guys, I am Sandip sir. I am a mechanical engineer and today we are going to study the concept of stress and strain. So first we'll see the meaning of stress. So to understand the meaning of stress, we'll consider one rod having diameter d and length L. So here this is a rod having diameter d and length L on which this pull force is acting. The nature of this force P is pull in nature. So here this is the L, that is the length of rod. So the effect of this pull force on the rod will be a tensile effect. That means there will be what tension produced inside the rod, and due to this tension, this rod may get failed after some time. So after failure, or we can say across this section, this rod will fail. This section is XX. So after failure, this rod will be divided into two parts. So this is the left side part, this is the right side part on which this force P is acting. So before failure, the rod will resist the external force applied on it, and this resistive force will be exactly opposite to the applied force. So here I consider this right side part for the analysis. So this resistive force will act in the opposite direction of this applied force P. So here I consider this resistive force is R, and this resistive force is acting on this area. So this area becomes a resistive area. So ये रॉड के ऊपर हमने पुल फोर्स अप्लाई किया था, और वो पुल फोर्स के कारण ये रॉड क्या हुआ, दो पार्ट में डिवाइड हुआ. बट ये रॉड तब फेल होगा जब उसका रेजिस्टिव फोर्स अप्लाइड फोर्स से कम होगा. इनिशियली क्या करेगा, रॉड पहले ये फोर्स को रेजिस्ट करेगा. जब उसका रेजिस्टेंस पावर जो है वो खत्म होगा, तब रॉड विल बी ब्रेक इनटू टू पार्ट्स. सो the stresses induced, अब stress क्या है exactly? It is the resistive force upon the resistive area, or we can say the internal resistance developed inside the object because of this external applied force. So mathematically we can write stress is equals to this resistive force R divided by resistive area A. But this resistive area A, and this is the cross section of the object. This resistive area, this cross section is same. So if I consider this is a circular rod, so area of cross section becomes pi by 4 into d square. So we can write sigma is equals to R upon A, whereas A for this particular bar is pi by 4 into d square. And if we apply condition of equilibrium for this rod, and if we apply summation fx is 0, then you will get what? R is equals to P. So I'll write here R is equals to P. So the mathematical expression of the stress is equals to internal resisting force, that is R, divided by area of cross section, or we can say resistive area. So sigma is equals to P by A, W by A, F by A, or this R by A. Whereas P, W and F are the external force applied on the rod divided by area of cross section. As the stress is the ratio of force upon area, the unit of force is Newton and unit of area is meter square. So unit of stress will be Newton per meter square. You may write Newton per mm square or Newton per centimeter square. So there are different types of stresses. Remember, the types of stresses are depends on the types of loading. So before loading, we'll see the stresses. First is the longitudinal stress. In longitudinal stress, there are two types: tensile stress, compressive stress. Then volume or hydraulic stress, and then shearing stress. So longitudinal stress means stresses which are developed inside the object along the length of the rod. So along the length, two types of stresses are developed: tensile and compressive. Now, here I consider one rod again, on which if we apply a tensile load P, due to this load, the stress induced in this rod is a tensile stress, because applied force is what? A tensile in nature. If I change the direction of this force, then this force becomes a compressive in nature. So stress induced will be what? Compressive stress. That means टेंसाइल एंड कॉम्प्रेसिव स्ट्रेस का जो नेचर है वो फोर्स हमने अप्लाई किया है उसके ऊपर डिपेंड है. फर्दर ये दो स्ट्रेसेस को हम डायरेक्ट स्ट्रेस या फिर नॉर्मल स्ट्रेस भी कहते हैं, बिकॉज द अप्लाइड फोर्सेस आर परपेंडिकुलर टू द एरिया ऑफ क्रॉस सेक्शन. जो फोर्स हमने अप्लाई किया है वो क्रॉस सेक्शन को क्या है? परपेंडिकुलर है. सो दिस इज ऑल अबाउट लॉन्जिट्यूडिनल स्ट्रेस. नेक्स्ट इज वॉल्यूम और हाइड्रोलिक स्ट्रेस. Volume or hydraulic stress means, if I consider one block over here, on this block if I apply force P in all directions, remember this P should be constant in all directions for hydraulic stress. So if P is constant in all the direction, the change in size of this block will take place. That means all dimensions of this block will change, but the shape of this block will not change. यानी कि पहले वो क्यूब था मान लो, तो एंड में भी वो क्यूब ही होगा, बट उसका साइज कम होगा, उसका शेप चेंज नहीं होगा. सो वॉल्यूमेट्रिक स्ट्रेस और हाइड्रोलिक स्ट्रेस. नेक्स्ट इज shearing stress. The stresses which are induced inside the component because of shear force. Now we have to know the meaning of shear force. So shear force means the forces which are parallel or tangential to the cross section. For example, suppose if I consider this is again a rod having diameter d, and if I apply force in upward direction over here and downward direction over here, that is P. The effect of this force, or we can say after some time this rod will fail across this section axis. So after failure, if I draw a diagram of right side part of this rod, then this will look like this. So this is the area under failure or area of cross section. Or now relation between this area and this P or this P. This P is what? Parallel to this cross section or tangential to this cross section. So due to this force or tangential force, जो stress induced होगा उसको हम कहेंगे shearing stress. The stresses which are induced inside the component due to shear load is the shearing stress. Stresses which are induced due to hydrostatic force is volume stress or hydraulic stress, and stresses which are induced due to tensile load is tensile stress, and due to compressive load is the compressive stress. In short, stress का जो cause है वो है force. जो type का force होगा वो type का stress induce होगा. Now we have to see the concept of a strain. So as per the definition, the strain means a change in dimension of object upon original dimension. Means after application of force, कोई भी object है उसका deformation होगा. Deformation means change in dimension or change in size of the object due to external force. So strain is change in dimension upon original dimension. Again we consider one rod whose one end is fixed, other end is free. So left side में यहाँ पे fix किया है और इसके ऊपर मैंने tensile force को apply किया. So I'll apply a tensile force over here. So due to this tensile force, the length of this rod will increase and diameter of this rod will decrease. So increasing length, तो मैंने कहा delta L. Delta L is a change in the length of the object. L is the original length of the object. So change in dimension upon original dimension is a strain. So change in dimension अगर यहाँ पे मैं length consider करता हूँ divided by original length करता हूँ तो meter per meter cancel होगा. So strain has no unit. Strain has no unit. अब unit strain को unit नहीं. Now types of strain. First is a longitudinal strain. This longitudinal strain is also called as a linear strain. Longitudinal strain means change in linear dimension. Longitudinal strain means change in linear dimension upon original linear dimension. Change in linear dimension upon original linear dimension is linear strain. So अगर यहाँ पे देखोगे तो change in linear dimension means dimension of object along the axis of the rod. So यहाँ पे change in length है, that is delta L upon original linear dimension is what L. So linear strain यहाँ पे होगा change in length, that is delta L upon L. So this is linear strain. Next is a lateral strain. So lateral strain is change in lateral dimension upon original lateral dimension. So first we have to know the meaning of lateral dimension. अगर आप circular cross section का rod consider करते हो तो यहाँ पे जो diameter है, diameter will be the lateral dimension. And if you consider a rod having a rectangular or a square cross section, then the lateral dimension will be B and T, that is width and thickness will be the lateral dimension. तो ये जो डायमेंशन में चेंज है डिवाइडेड बाय ओरिजिनल डायमेंशन यानी कि डेल्टा D by D, डेल्टा B by B, डेल्टा T by T will be the lateral strain. Further, volume strain or volumetric strain. So simple है, volumetric strain is change in volume upon original volume. We can write here that is delta V upon V. Change in volume upon original volume. Now a shear strain. The strain developed due to shear force. For example, here we consider one block again. So मान लो यहाँ पे एक ब्लॉक है और ये ब्लॉक के ऊपर मैंने यहाँ पे एक फोर्स अप्लाई किया मान लो P. So this P is a tangential to the top surface. If I draw a 3D diagram over here, then it will look like this. So this P is what tangential to the top surface. This point I consider A, this point is B, this point is C, this is D. Now AD is fixed and force applied is at the top surface. So due to this force P, B may shift to point B dash and C may shift to point C dash. तो जो फाइनल इफेक्ट होगा ये P का, AB लाइन है वो A B dash होगा, CB लाइन है वो D C dash होगा. So the change in position or you can say change in AB, AB पहले perpendicular था, vertical था, अब वो inclined हो. So यहाँ पे जो एंगल जनरेट होगा वो होगा phi. And this phi means angular distortion of the object due to this shear force. And this angular distortion is nothing but a shear strain. So this is the concept of strain and stress.